Hi, welcome to this course of Basics of Blockchain. In this first video, we will understand what blockchain is, what are some of the prerequisite key terms we need to understand, and how blockchain is a combination of multiple singular elements. So first of all, the most basic elements of blockchain is cryptography, symmetric key and asymmetric key cryptography, hashing, data dealing, and P2P network. Now we'll go into deep in all of these topics as we go progress in the slides, because to understand blockchain you will have to be very clear with these topics. So what is cryptography? Now cryptography is the art of converting plain text into cipher text and then converting cipher text into plain text. It involves conversion of data into a secret or a cipher text, and that secret text or a cipher text can be decrypted as plain text at the receiving end. Let's take an example. This is a plain text file in which I want to send a message. Now let's suppose this message is a very confidential message and I don't want anyone else other than the person who is meant to see this message can read it. So what I'll do, I'll encrypt this message. So after encryption, it will look something like this. So it becomes totally unreadable for the human eyes. You cannot process what information this is without the decryption key. Now there are two types of cryptography: symmetric key and asymmetric key cryptography. In symmetric key cryptography, there is always one key used for encryption and decryption. Let's take an example. Symmetric key cryptography is a very old technique. It basically started with Julius Caesar. That's why the first cipher that was ever known is called as Julius cipher. What he did when he used to send messages across kingdoms, he did not trust his messengers a lot. So what he used to do, he used to encrypt his messages and only the receiving person could decrypt it. Now in those days, how was he able to achieve this? So he decided something what we call as a +3 shift. So suppose there is a message A, B, C. So a +3 shift will give it D, E, F. So if he wanted to send ABC, he would have sent DEF. Now the messengers were unable to read this. The receiving party knew what the key was. They knew that the key was 3 and they would apply a -3 shift. So a -3 shift applied to DEF would result in ABC. So this is how symmetric key cryptography came into place. Since then it has been very highly useful in various factors and fields. In our daily day-to-day life, we can see it like people want to encrypt their files, which is secret, confidential. Encryption means they don't want anyone else to read it. Our daily communication over the internet are encrypted because we don't want anyone who is listening on the communication should see what we are sending and receiving. But symmetric key cryptography had a problem. The problem was both the receiving and the sending parties should decide mutually what the key would be. So at some point of time they would have to meet and decide the key mutually and then take their keys and then they can separate. But if one of the keys is compromised, then they will have to meet again and reset the keys. They cannot do it remotely because sending a key over the internet which is not secured can be sniffed by anyone in between. So to overcome this limitation, asymmetric cryptography came into being. There were two guys, Diffie and Hellman. They decided to make a system through which people can transact over the internet using keys, and no one will be able to see what they are transacting because it will be encrypted, and they will use two keys to decrypt and encrypt. And in earlier days, it was thought of a silly idea, but somehow it came into being. So in asymmetric cryptography, we use two keys, a public key and a private key. So as the name suggests, the public key can be distributed to the public. It can be hosted at a public network, but the private key should be kept private. Now at the sender end, if A wants to send a message to B, what A will do, A will encrypt message with B's public key. Now B's public key is publicly available. He may even send the public key to A over the internet over a unsecured network that is completely safe, because the public key is only used to encrypt the data. Now the encrypted text will go to B, and B will be able to decrypt the text using his private key. Now anyone who has the public key can only encrypt. So someone is sending an encrypted message that is encrypted with public key. If someone intercepts in between, they cannot decrypt it with a public key. They will need to have the private key. So this is how a private and a public key scenario works. It is right now the widely used phenomenon, because we are almost every information is passed over the internet is confidential. So to keep that safe, we will have to use asymmetric cryptography, because we cannot use the same key for encryption and decryption over an unsecured network. So we'll understand this better with the color theory. So we have two participants, A and B. They both know a common color, that is yellow. Now A also knows yellow, B also knows yellow, and they both have a private color. A has a private color red, B has a private color blue. Now A and B are both aware of their own private color, but they are not aware of the other party's private color. So A does not know that B's private color is blue, and B does not know that A's private color is red. But they want to reach to a consensus so that the message they both have is same. So how we can use this is, A and B, they both mix the color yellow that is publicly available into their private colors. So A mix red with yellow and B mix blue with yellow. It results into some color. Now when A is mixed with yellow, B does not know that the resulting color is a combination of what colors. So they both will interchange the combinations. Now they are not sending the private keys, they are only interchanging the combinations of the private color with the public color. Now they both have each other's combination. Now to reach a consensus so that they both should have the same data, they will add their own private key. Now adding their own private key into the combination would result in the same color. So A also has blue, yellow and red, B also has blue, yellow and red. But A knows two colors. A knows yellow and red, and B knows yellow and blue. From the combination, they cannot figure out what the color of the other person was. So that is how the private key is kept secured. Now this is a video. Let's play this one. Okay, so I hope you got the idea of cryptography from the video. Now this is also how public key cryptography and digital signatures are used in cryptocurrencies. So first of all, we just now studied what is public key cryptography. That is a combination of two keys, public and private, that is used to do communication over the internet. Now what is a digital signature? Now digital signature is basically a, a math function that uniquely identifies its creator. Now, you can sign a document using your private key. Now, signing a document or generating a digital signature means a combination of the private key, the hash of the document, and the document will generate the digital signature. Now, if I am sending a document with my digital signature that is created with my public key, I cannot deny that I did not created it, or anyone else cannot prove that they created it because it has my digital signature. It is analogical to the physical signatures that we use in our day-to-day life. So someone's digital signature is on a document, it belongs to them, that is signed by them. Now what is a hash function? It is a method to guarantee data integrity. It gives fixed length output for any variable input. It is a one-way function, and hashing function used in bitcoins is short to 56. So a hash function is a one-way function in which you provide any variable length input. It could be a single letter A, or it could be a file of 25 to 50 GB, anything you want, and it would always give a fixed length output. Now that fixed length output is uniquely related to that particular file we are hashing. So any minor changes in the file will completely change the hash, and that is how hash is used to maintain integrity. So when data is tampered, we can match the hash. If it's the same, then the data is not tampered and it arrived at the same state as it was sent. And if the hash function results in a different value, that means the data is tampered in the way. So in a real life example, a day-to-day life example, when we download a software, let's say a Linux image from the internet, they always provide a hash value along with the image. What we are supposed to do is when we download the image, we are supposed to calculate the hash so that we can match whether the hash mentioned on the server and the hash we are getting is the same or not. If it's the same, that means we got exactly the same file that is hosted on the server. If it's not on the same, that means somehow our file got corrupted while downloading and it may not function properly or the way it is meant to function. So a hash of different characters is different. So if I write my name in all capitals, it will be a different hash. If I write my name in all smalls, it will be a different hash. And if I write my name in one capital, one small format, it is also a different hash. So any minute changes in the input could result completely in a different hash. Now data diddling. Data diddling is changing data or modifying data for fun or profit. Data diddling can affect banks, payrolls, inventory records, credit records, school transcripts. So basically, when you modify or tamper with the data you are not supposed to do, or that may not result in the correct output, it's called data diddling. So in blockchain, when we work on blockchain, we need to download the whole of the blockchain. So basically, we have whole history of the blockchain, and if we want, we can even edit the data. If we edit the data on the blockchain or any other server, that is called data diddling. Now what is the P2P network? A P2P network is basically called a peer-to-peer network. In the left image, you can see a server-based network. In this network, all the computers are connected to a single server. For example, let's suppose a college server. There is a college which keeps all its document, all its inventory over one server, and all the students are connected to that server to access their records. So that is what we call a server-based or a centralized network, in which there is always a single point of failure. As soon as the server gets corrupted, all the points fail and no one is able to get the service. What P2P network here is, there is no centralized server and every node is connected to every other node and they are continuously communicating. So in this case, even if a few nodes go down or if they get corrupted, the rest of the nodes are active and they are actively participating in the communication, and that way the communication does not stop. So basically there are three types of network: centralized, decentralized and distributed. For the example of centralized, I mentioned the caller server. That is a perfect example of centralized server in which all the computers, all the systems are connected to a central server and they transact or communicate with that single server. For decentralized, when we have servers located at different locations. So let's suppose we take an example of Google. Now Google has the servers located at multiple locations having the same data. Now there is also the single point of failure problem is removed from here. There is always a backup server. A server goes down, the next server goes up. But still there is one governing authority. Like all the data centers of Google are managed by Google. So if Google decided, they can change or manipulate the data, they can restrict the access. Then we have distributed networks. Distributed networks means data is distributed at multiple places, similar to a decentralized one, but there is no central governing authority. So when suppose someone decides to go rogue or the government decides to shut down the network, they cannot shut down a decentralized network because every node is talking to every other node. Even if they are successful in shutting down a few nodes, the rest of the nodes are active and they are continuously participating in the communication. And the data gets updating at every moment, at every node. Now, what is blockchain? Let's understand this with a video.
Modern technology allows people to communicate directly. Voice and video calls, emails, pictures and instant messages travel directly from A to B, maintaining trust between individuals no matter how far apart they are. When it comes to money, people have to trust a third party to be able to complete a transaction. Blockchain technology is challenging the status quo in a radical way. By using math and cryptography, blockchain provides an open, decentralized database of any transaction involving value, money, goods, property, work, or even votes, creating a record whose authenticity can be verified by the entire community. The future global economy will move towards one of distributed property and trust, where anyone with access to the internet can get involved in blockchain-based transactions, and third-party trust organizations may no longer be necessary. The uses of blockchain technology are endless. Some expect that in less than 10 years it will be used to collect taxes. It will make it easier for immigrants to send money back to countries where access to financial institutions is limited. Financial fraud will be significantly reduced, as every transaction will be recorded on a public and distributed ledger, which will be accessible by anyone who has an internet connection. Think of it as wills and contracts that execute themselves, or dated proof of existence for ideas, much like a patent. Blockchain will become a global, decentralized source of trust, but not everyone is ready to embrace it. A huge proportion of trust services, from banking to notaries, will face challenges on price, volume, and in some cases, their very survival. Public authorities could find it more and more difficult to enforce traditional financial regulations due to the new possibilities offered by the Bitcoin network to bypass traditional financial intermediaries. Unimagined new networks will evolve to meet society's needs more cheaply and potentially more securely. Will governments, financial and legal institutions embrace blockchain? What will happen to the ones who don't?
So to get started with blockchain, I think that videos are perfect because it showcases how Bitcoin can be used at multiple places and what effects it will have on a society. So there is something called timestamp. To timestamp a document so that it is not possible to tamper the data. It was introduced in the year 1999. So timestamp means there is something called epoch time or the Linux time. It is number of seconds that have passed from January 1st, 1970. That is what we call as epoch time. And it is basically used at all the high-level programs or even blockchain or any cryptocurrencies. That is the method of timestamping. Timestamping means when I produce some data, I can timestamp it at the time I produced it, and then no one can deny me the right that of provenance. So if someone other than me produce the same data later on, I can showcase, I can prove my point that I produced it better first because I had the earlier timestamp. Now, tamper-proof data in distributed networks, it is implemented by using hashing. Now, decentralized, it is using peer-to-peer networks, and security, it uses cryptographic function. So, blockchain is not one thing. Now, blockchain is a combination of multiple factors which have been evolved or which have been invented in the earlier days. Blockchain combined all of them effectively and then came up with a solution that the world needs to store data publicly, which is not which is immutable and can prove provenance with the help of timestamping, and is completely safe.